Hello friends, this is Vidushi and today I have brought chapter 3 of chemistry, atoms and molecules. So what is an atom? Firstly, what is an atom? Atoms are the smallest particles of matter by which a matter is made. This chalk has small atoms. Small atoms in it, millions of atoms. This board has also millions of atoms. So everything that is matter is made up of atoms and molecules. So atom is the smallest particle of a matter or the building block of matter. Or another definition, atoms are the smallest particles which takes part in a chemical reaction. So let's see what is the discovery of atom. How were the atoms discovered? Atoms were discovered firstly by Indian philosopher Maharshi Karan. He was Indian philosopher and he proposed that every matter is made up of small particles called anu and which are further divided to get parmanu, and parmanu is the atom. This pretty is the atom which he named as parmanu. So 500 BC ago he proposed that every matter is made up of small anu and anu which further divide to make parmanu. So this was given by Maharshi Karan. Now let's see, after some time different scientists came and they proposed also the same thing, but at last in 18th century they recognized that we have to make differences between everything because different people have said different things, they have their own different types of statements, so we have to combine together and watch it out, or we have to collect it out which is the best one. So that best one is the matter is a particle. The matter is made up of smallest particle which is called an atom. Now let's see what is the law of chemical combination. The law of chemical combination can be divided into two groups: law of constant mass, law of conservation of mass, and law of constant proportions. So these two were given by different scientists. Law of conservation of mass states that mass can neither be created nor be destroyed in a chemical reaction. Mass can neither be created nor be destroyed in a chemical reaction. So this was given by Antonio Lavoisier in 1774. He was the scientist who proposed that mass can neither be created nor be destroyed in a chemical reaction, and this is known as law of conservation of mass. Conservation means everything remains constant. Now law of constant proportion. As the name is suggesting proportion, so there must be same proportion. So this law states that in a chemical combination, in a chemical reaction, the elements are always present in a definite proportion by mass. So this was given by Joseph Proust in 1799 after Antonio Lavoisier. He states that in a chemical reaction, the total amount of elements present are in the equal or in the fixed ratio and proportion. Let's see by an example. For example, in the law of conservation of mass, we will take an example CO2, which is carbon dioxide. Then CO2 means carbon and oxygen are combining together. So let's see C plus O2. What is the mass of carbon? Yes, it's 12 gram. And mass of oxygen? The mass of oxygen is 16, but the two molecules are present, so 16 to the 32. So there are 32 grams of oxygen here. So 12 plus 32, 44, and which is the mass equal to carbon dioxide, 44 grams. Means law of conservation of mass, mass can neither be created nor be destroyed. The total mass remains conserved. This is also 44 grams and this one is also 44 grams. So this states that mass can neither be created, nothing is added or subtracted. So the total mass remains conserved. Let's see an example of law of constant proportion. For example, H2O means water. Water is made up of hydrogen and oxygen. Hydrogen and oxygen combine together to make water. Now, hydrogen, what is the mass of hydrogen? Yes, it's 2. And mass of oxygen is 16, and though there are 2 molecules, then therefore it is 32. But this equation is not balanced. If we balance it, then here 2 and here 2. Now 2 hydrogen. Now 2 to the 4 and 4, there are 4 hydrogens, so we have to put it here 4. 4 hydrogen and oxygen are 2, so there are 2. So if we add here 4, then the mass of hydrogen is 2, but it doubles, then it becomes 4. Now it's balanced chemical reaction, so now we have to put it here proportion. If we cut it out, then 1 and 8. 1:8. Hydrogen and oxygen molecules will combine in the ratio 1:8 to form water molecule. From anywhere you bring some water, even from the moon, from the sea, from your own house tap, anywhere the proportion of water molecules always be 1:8, and that is fixed. So this law is a law of constant proportion. States that every element is combined in a fixed ratio by mass, and that's fixed for different elements of different compounds. Now we'll come to the next. Dalton's atomic theory. Dalton's atomic theory is based on law of chemical combinations, means law of constant proportion and law of conservation of mass. So he discovered different points. He has different statements which was based on law of chemical combination. So let us discuss what are these all different statements given by him. He just gave the statements, following statements. They are atom. He just proposed that the word atom means indivisible, which cannot be divisible by any other means, which we cannot divide further. It is the smallest stage that is called atom. The word atom means indivisible, which cannot be divided further. So let us see what are the different statements given by Mr. Dalton in 1808. So every matter is made up of tiny particles, which is called matter. We all knew that, it's very common. So atoms are indivisible, and it is which cannot be created nor be destroyed in a chemical reaction. We have studied it in law of conservation of mass. Then atoms of a given element are identical in mass and chemical properties. The mass and the chemical properties of atoms are totally same. Means if we break down this chalk, then the chemical properties will not change. In the first piece, it will also remain same, and in the second piece, it will also remain same. So there is no change in chemical properties if we break it out or destroy it. We cannot destroy the matter because atoms cannot be destroyed, cannot be created. So atoms of different elements have different masses and different properties. As there are different atoms, there are different elements in our chemistry, in our periodic table. So different elements have different properties, different chemical properties, and different masses. We all know that, it's very common. So atoms combine in a ratio of whole numbers. They cannot be written in a fraction or they cannot be written in a decimal. They are always a whole number and they combine to form compounds. Elements combine together to form compounds. We have studied in the last video. The relative number of types of atoms are considered in a given compound. The relative number and type of atoms are constant in a given compound. So this was there were 6 points which Dalton states. Now we will come to the next topic. Now let's discuss what is the atom of different elements. Atom of different elements means there are different types of elements, and what are the symbols? What are the different symbols for them to write it down to make different types of chemical reactions in the equation form. So what are these words for writing the elements? Let's see now. So John Dalton was the first person who discovered the process of making elements for writing the short names. These symbols are used for making the so much long is very short. So he used the different types of symbols for gold, copper, and tin, oxygen, etc. So actually there are 180 elements in our modern periodic table, and it is not easy to learn all those 180 elements with symbols. Can you memorize 180 symbols? It's not easy. So the scientists have found different types of ways to write it down in different way. J.J. Berzelius, he was the first scientist who discovered how to write different elements by using their symbols. So firstly, there are 6 ways to write, how to write the symbols of different elements. So let's see, first the starting letter. From which letter the element is starting? For example, oxygen, symbol is O, that means first letter, which is O. Nitrogen means N, first letter is N. So fluorine for F, so F is for small, this is a single starting letter. So there are many others. Second is first 2 letters. We have to take first starting 2 letters. For example, neon, N-E-O-N, so N-E, we have derived it. For and another is aluminium, A-N, for and helium, He, xenon, Ze, Xe. So there are different types of elements which are named after first 2 letters, first and the next letter. Now based on their Latin names, some were similar to each other. For example, oxygen. So there were different elements which are similar to each other. So we will use their Latin names for them. J.J. Berzelius thought that it is not easy to memorize the different words or different symbols in first 2 letters and first letter starting, because many letters are starting with the same. So he used the Latin names. For example, sodium, Na for natrium, its Latin name is natrium. W for tungsten, which is wolfram. So there were such Latin names which were discovered by J.J. Berzelius, and place where were they firstly found. Some elements were named on the place where they were firstly found, in which country the place where they were firstly found, they have taken the name from there. For example, copper from Cyprus. So Cyprus is the country, and the element where they were found firstly, they named copper. So it was similar to Cyprus. So this was the name of elements which were where they were firstly found. Now specific color. For example, gold. In English, gold means yellow. So gold gold, etc. First and next letter later. Here and here there are difference between it. Here we are taking first two letters, and here we are taking first letter and another next letter, whatever it is, third, fourth, fifth, etc. Whatever it is. But we are not taking the second one because it has already taken. We have already taken here. So here we have to drop down the second letter and we will take any letter, but which the scientists have made, we have to write that. We cannot add it with ourselves, so we have to write that one first and next letter later. For example, chlorine, CHLORINE. So CHL, the third letter is put with C. First letter, third letter and first letter, they are combined together. So this was the example ZINC, zinc. So they have taken first and third letter, Z and N. So this was the example for first and next letter. And nowadays IUPAC, International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. So nowadays IUPAC discovered what the new elements which are being discovered will be will be the symbols for them. So nowadays IUPAC is deriving them. They have the full authority to write down the symbols with their own ideas. So this was how to write the symbols of different elements. Now we will move to next. What is the significance of symbols? We have made different types of symbols. So what is the significance? What is the use or what is the benefit of making symbols like these? So the benefit of making symbols is it requires less time because writing too much of long spellings will take more time in exams and we will drop just 2 or 3 questions. So it will take less time to write down and it saves our time and it needs very little space. You know, very long spellings takes very more space. So it takes very little space because there are just 2 or 3 letters in the symbols. So it requires less time and less space, and they are easier to write, fast to write, and they represent the atom of an element and name of that element because mostly they are based on Latin names and first letter in this starting letter is also there, in this one starting letter is there, and this one is also starting letter is there. They are naming the place where they were found, Latin names and specific color because these are based on their own languages which we have to learn it. But now these starting letter, there is first starting letter, first 2 letters, it is also first starting, first is there now. Then in the first and next letter, first is also there. So first, we can easily signify what is the symbol of that element. So now we will discuss next. Now we will come to atomic mass or mass number. They both are same. Atomic mass or mass number both are same. So in this portion we will cover up what is AMU, atomic mass unit. It is also denoted by small u. Denoted by small u. So AMU, atomic mass unit, can be defined as the one atomic mass of any element which is exactly equal to 1/12 of carbon 12 atom. The atomic mass which is exactly equal to the 1/12 atom of carbon 12 means carbon 12. There are so much of isotopes of carbon, so that's why carbon 12, carbon 13, carbon 14. So we have taken here carbon 12. So it is equal to the carbon 12. We have taken the reference as carbon 12, and C12 is the reference by which we can we can find out all the atomic masses of element. So this is what called AMU, atomic mass unit. So this was atomic mass unit. And what is atomic mass? Atomic mass is the mass which the total presence of protons and neutrons in an element is called atomic mass. Total protons and neutrons present in a nucleus of an atom is its atomic mass. Atomic mass. It is represented by A, capital A, and the number of electrons the number of protons, it's not electron, it's proton, which is present in the nucleus of an atom. The number of protons, the total number of protons in an atom or nucleus of an atom, the total number of protons is denoted by Z. It is denoted by Z and it is called atomic number. Atomic number, and it is denoted by capital Z. So total number of protons plus neutrons, atomic mass, and protons, total number of protons in nucleus is atomic number. So atomic mass is represented by capital A and atomic number is denoted by capital Z. So this was the atomic mass and atomic number, the difference between atomic mass and atomic number. So protons present in nucleus is atomic number and protons plus neutrons present in nucleus are atomic mass. So this was the difference between atomic number and atomic mass. So any element, if we want to write atomic mass and atomic number of any element, suppose the element is X, then we will write the atomic mass above and atomic number below. In the atomic mass is above and atomic number is below. You can also understand that A is the first letter and Z is the last letter. So first letter will come first and last letter will come last. So this is the trick for memorizing which will come in the top and which will come at the bottom. For example, oxygen, O. The mass, atomic mass, what is the atomic mass of oxygen? It's 16 and atomic number is 8. So we will write mass above and the atomic number below. So this was atomic mass and atomic number. Now how do atoms exist? Do atoms exist independently? Yes. Atoms exist independently. They cannot exist independently. They will combine together to form molecules, and this is what is called molecule. Atoms combine together to form molecules. So now we will discuss what is a molecule. A molecule is the substance which is made by combining two or more atoms chemically. They cannot be separated by physical method. They can only be separated by a chemical means or chemical method. So molecules can be classified into two: molecules of element and molecules of compound. So molecules of atom are same type of atoms which consist of same types of atoms. That is called molecule of an element. And molecule of a compound is a combination of atoms of different elements. Atoms of different elements join in different proportion. Means there are different proportion, there are different ratios in it because it is a compound. So compound consists of many atoms and different elements. Atoms of different elements and they have different proportion. We have seen the example of hydrogen in the few minutes ago. So now we come to atomicity. What is atomicity? The number of atoms contained in molecule of a substance. Number of atoms present in a molecule of substance is called its atomicity. Now elements can be divided into three groups: monoatomic, diatomic and polyatomic. Monoatomic, mono means one. One atom. The one atom is present in elements. For example, hydrogen, argon, sodium, aluminium, copper and iron. Diatomic elements, or for example, diatomic is two elements. There are two atoms present in the element. For example, O2 means oxygen, nitrogen, hydrogen, chlorine, etc. Now polyatomic elements. Polyatomic means poly is many. There are many. So it is further divided into two: triatomic and tetraatomic. Triatomic means there are three atoms, and tetraatomic means there are four atoms present in elements. So triatomic, for example, O3 means ozone, and tetraatomic T4 phosphorus, and polyatomic means there are many atoms present in that element. For example, sulfur. It has 8 atoms present in that element of sulfur. So this was the classification of elements. You can also take a screenshot. Now we continue with what is an ion. I-O-N, ion. What is an ion? Now we will discuss what is an ion. Ion is a charged species formed by loss or gain. They can lose electrons or gain electrons, or electrons are known as ion. Means loss or gain of electrons, which have some charge, positive or negative, that is called ion. What is polyatomic ion? As the name is suggesting, poly means many. So the group of ions which carry a charge or a net charge on them is called polyatomic ion. So ions can be divided into two: cation and anion. Cation are positively charged and anion is negatively charged. So cation is formed when the element loses the electron. When it loses the electron, then it gets positive charge, just opposite to each other. And anion is formed when some element gain the electrons, then it gets negative charge. So somewhat little bit different from each other. Loss means positively charged and gain means negatively charged. So this is cation and anion. Now we'll discuss what is chemical formula. So now we will discuss what is a chemical formula. A chemical formula is the symbolic representation of compounds. The symbolic representations of compound is known as chemical formula. For example, a smallest simple formula consists of at least 2 elements. Minimum 2 elements should be present in a chemical formula. Simplest chemical formula. For example, CO, carbon monoxide. Carbon and oxygen. 2 elements are present here. So this is a chemical formula. Simplest chemical formula. And for example, multi means polyatomic. Polyatomic means CO2 means carbon is 1 and oxygen are 2 here. So this formula consists of 3 elements. Means 3 atoms. Elements are 2 but atoms are 3. 1 is carbon and 2 are oxygen. So this is CO2, carbon dioxide, and such as H2O. There are also 3 atoms present in it. Hydrogen 2 and oxygen is 1. For example, there are many examples: AgCl, BrCl, there are many examples. So chemical formula is the simplest formula consists of at least 2 of the elements. 2 of the atoms. Now we'll come to valency. What is valency? The combining capacity of elements is called its valency. Let's understand what are its rules. The combining capacity of elements is combined capacity of elements is called valency, and the atoms can be shared, lose or gain to obtain the octet state. Octet state means 8, sum of 8. The valency always occur in the formula or in the series. In this series, firstly 2 electrons in first shell, then 8, then 8, then 16, then 16, then 32, then 32, then etc. It occurs in such a series. First shell, second shell, third shell, fourth shell, fifth shell, sixth shell, seventh shell, and etc. up to 180 elements. So, in the first shell, the electrons must be 2. There must be 2 electrons. For example, hydrogen has only 1 electron. So, to obtain its octet state, it has to gain 1 or lose 1 electron. If it will gain, then it will become 2. And if it lose, then it will become nothing. It will lose. So, sharing also occurs. For example, carbon has 40 is 2. The atomic number of atomic mass of carbon is 12. So 12 can be written as 2 and 10 means 2, 8 and 2. So it will lose 2 electrons. So such sharing is also there, and losing and gaining. So their elements or compounds the elements will combine and form the octet in the series. First, second, third, fourth, and such a shell is formed in such a series. So if you will remember this, then it is very easy to understand valency. So now we will see some examples and some rules of valency. So here are some rules for we have to remember before using the valency. So first is the valency or the charges on ion must be balanced. There must be balanced valency. When there are metal and non-metal in a compound, then metal is written first. For example, NaCl, sodium chloride or common salt. So Na is the metal and Cl is the non-metal. So metal is written first and non-metal is written after the metal. So compounds formed with polyatomic ions, the compounds which are formed when polyatomic ions combine together, then they are enclosed by bracket before writing the number. How much valency is there? So before writing the number, we have to just enclose them with a bracket to indicate the ratio, to indicate how much ratio is in the particular compound. For example, CaOH whole twice means calcium hydroxide. So this whole twice means this 2 is the valency of O and H also. So bracket means there is the indicator number is on the board. So instead of writing CaO2 and H2, we will take 2 as common and write it out outside like this. This one would be wrong. This is the wrong method to write a chemical formula. So now let us discuss what are the simple compounds. As we have discussed it earlier, the simple compounds must have at least 2 atoms in compound. So minimum two and two compounds are known as binary compound. So minimum compound should be two. That is the simple compounds. And now we will discuss what is molar mass, mole concept, and formula, mass unit, etc. Now, here are some rules for writing the chemical formula by using crisscross method. Crisscross means just zigzag. So, writing the symbol of elements. First, write the symbol of element. Which formula do you want to take? Write the symbols of that elements. Then write the valency of element above that symbol. Above that symbol, we have to write valency. Then crisscross the valency means just make the opposite valencies and write in the subscript or the bottom of the formula. When subscript is 1 or equal, when there is one subscript means 1, you can understand it when a fraction is rational and it has 1 in the denominator, then we don't write the denominator 1. So same thing is here, when subscript is 1, then we will not write any of the subscription, and when they are equal, for example 2 and 2, subscript are 2 and 2 equal subscript, then it will cancel out and we will not write it at all. So if there are multiple number of polyatomic ions, then brackets must be used to separate it from subscription. The bracket is the major thing which will separate the whole polyatomic ions from the subscription, otherwise it will make something else sense. So let's understand by an example. For example, HCl means hydrochloric acid. What we have first write the symbol of elements hydrogen and chlorine. So this is the symbolic representation of hydrogen and chlorine. So then what we have to write? Valency of element above the symbol. The valency of hydrogen is +1 and chlorine is -1. We have written the valencies. Then crisscross the valencies. Then we have to just exchange the valencies and write it down in the subscription. So H1 means crisscross and Cl1. Since it is 1 and 1 means equal valencies, so the valencies should not be written in subscription. So here we will get the formula HCl, hydrochloric acid. So this was the simple example of valency. Now we will do the multiple polyatomic ions, how they are being separated. The example of polyatomic ions in which we will use bracket is, let us take aluminium sulfate. Aluminium for Al and sulfate for SO4. So this is the symbol for aluminium and this is for sulfate. So what is the valency of aluminium? It's 3. Positive 3. And sulfate, it's -2. -2. Then crisscross the valencies, then we will get Al. This -2 will come in subscription and it will become 2. And one thing should be noted, that the valencies should when valencies will come in the subscription or subscript, then subscript should not have any positive or negative sign. We will not write this -2 here. We will just write 2. The cation and anion are in the valencies, but when it comes in the subscript, then there is no symbol written positive or negative in the subscription. Subscript. So Al2 and SO4. This whole is a one compound. So this valency will come down in the subscript as whole. So whole thrice. Because this valency is coming on the SO4 means sulfate, whole sulfate. So there we will use bracket. If we will not use bracket, then 4 3 is a 6. Sorry, 4 is a 12 and it will become SO12. So that's wrong. So we will just use the bracket. Otherwise, it will be wrong. So there are many examples you can practice at home, and you can also search for NCERT books. So now let us come to next. Now we will continue with the molecular mass and mole concept. First we will see what is molecular mass. As the name is suggesting, the mass of molecules. So it is the sum of atomic masses of atoms in a molecule. Mass, the sum of atomic mass in molecules. It's very simple. Sum of atomic mass in molecules. So molecular mass is the total sum. So let's see with an example. For example, H2O means water. What is the molecular mass of water? Let's calculate. So molecular mass of hydrogen is 2. Mass of hydrogen is 2 and oxygen is 16. So what will be the total molecular mass of the molecule? So let's see. 2. Atomic mass of hydrogen is 1. I was confused. So 1 into, since these are 2 atoms, so we will multiply by 2 plus 16, and it is 1 atom, so we will multiply with 1. And 1 into 16 is absolutely 16, so if we will not write into 1, then there is no problem. So 2 plus 16, that's 18 U. So this what is the molecular mass of water. Let's see another example. HCO3, hydrogen carbonate. So let's see what is the mass of what is the atomic mass of hydrogen? It's 1, and atomic mass of carbon is 12. Atomic mass of oxygen is 16. So 1 into 1 plus 1 into 12 plus, and since there are 3 atoms present in oxygen, so we will multiply by 3. So 3 into 16. So 1 plus 12 plus 16 3 is 48. And when we will calculate, 1 plus 12 is 30 and 30 plus 48 is 61. 61 U. So this is the molecular mass concept. Now we will discuss what is formula mass unit. Now formula mass unit is the sum of atomic masses of atoms in a formula unit of a compound. Here is the same sum of atomic masses of atoms in formula unit of a compound. Here, though it is a formula unit mass, so it will be formula unit of the compound, and here it was molecular mass, so it was in the molecule. This is the little difference between these two, molecular mass and formula unit mass. For example, NaCl, sodium chloride. What is the atomic mass of sodium? It is 23. And chlorine, it is 35.5. 35.5. 35.5. So it is the same process which we have done in the molecular mass. So we will multiply, though it is a 1, so it will multiply by 1 plus 35.5 and it is 1. So 35.5 into 1. So 23 plus 35.5, that is 58.5 U. So this was the formula unit mass of NaCl or sodium chloride. Now we will take another example, magnesium chloride, MgCl2. So what is the atomic mass of magnesium? It's 24. And chlorine 35.5. And now we will multiply 24 into 1 plus, here chlorine are 2 atoms, so we will multiply by 2, 35.5 into 2, then 24 plus 35.5 into 2 is 71, and which is equals to 95 U. So this was the formula unit mass of different elements. So now we will move to the mole concept, another important thing. Now let's learn what is mole concept. One mole of any species, this species may be atoms, molecules or any of the particles, is the quantity in number having mass equal to its, means the number of species that can be atoms, molecules or particles, and equal to its A. A is represented by atomic mass in grams atomic mass. So 1 mole is equal to 6.022 into 10 to the power 23 particles. The particles may be atoms, molecules. And this 6.022 into 10 to the power 23 is also known as Avogadro constant or Avogadro number. It was given by Italian scientist Avogadro in 19th century. That's why it is named after him, Avogadro constant or Avogadro number. Now let's understand what is molar mass. Now we can take a look for this diagram. Moles can be of 3 types: molar mass, number of particles in 1 mole, and molar volume. It is the volume of gas at STP, which is equals to 22.4 liters. So this is the diagram how to solve the concept how to solve the numericals based on mole concept. Let's see a look on them. I will tell you the different tricks for solving the different problems. So here are the 3 tricks by which you can solve any of the related numericals by which you can get the marks easily. So firstly, if mass is given, to find the mole, if we want to find the mole, number of moles, then the given mass into molar mass, then if we multiply given mass into molar mass, then we will get moles, number of moles. And if we want to reverse it, if mole is given and molar mass is given, and we have to just answer what is the given mass, then we will multiply mole by molar mass and we will get mass. So this was the first. Now second. So before going to second, I want to tell you something, that if we want to convert the reverse, then mole is given and molar mass is given, then 1 mole will become in denominator and molar mass will came in the numerator. It will become molar mass, I am writing in short, molar mass upon 1 mole. It will become reverse. Now in the second condition, when mole is given and we have to answer what is the volume at STP, then we will multiply moles by 22.4 into 22 into 4 liters upon 1 mole. Then we will get volume at STP. If volume at STP is given, then we will just reverse it, means 1 mole upon 22.4 liters. When we will just do this, then we will get moles, number of moles. Then when number of moles are given, then we have to answer the number of representative particles, means how many particles are there in the compound. Then we will multiply by the Avogadro number and divide by 1 mole. Then we will get number of representative particles. And if we want to just answer the number of moles and representative particles are given and 1 mole and particle and Avogadro number is also given, then we will just reverse it, means 1 mole upon 6.022 into 10 to the power 23 particles. Then we will get mole. You can also take a screenshot of it. So do the numerical practices based on these formulae and make sure that you will definitely get this chapter very easily. So thanks for watching this video, and for more videos like it.